Topic of discussion is trigonometry, but basically we know trigonometry is a large topic. So what we will do, we will be focusing mainly on the inequality in trigonometry. So basically we will be dealing with a particular part of trigonometry. First of all, let us take some sums which we have taken from KVPY, which came in the previous year's KVPY. So KVPY 2009, because these questions will help us that whether how to go to a particular topic or whether this topic is important or not. So KVPY 2009. Here given a set A, which is saying that theta belongs to R. The theta is a real number, such that 1/3 sine theta plus 2/3 cos theta whole square equal to it's 1/3 sine square theta plus 2/3 cos theta. And we have to find that what is the intersection of A with 0, pi interval, close interval 0, pi. Now the meaning is that you have to understand the meaning. That is what is they are asking for here in the question. A intersection 0, pi. That means basically in short those values of a set A which are lying in this interval. So for that what we will do? We will first simplify this equation. Then we can understand what is the possible solution of theta which will be lying. So we take this one. So we started in this so that we have 1/3 sine theta plus 2/3 cos theta whole square equal to 1/3 sine square theta plus 2/3 cos square theta. Now here on simplification we get 1/9 sine square theta plus 4/9 cos square theta plus 4/9 sine theta cos theta. 1/3 sine square theta plus 2/3, it is 1/3 minus 1/9 sine square theta plus 2/3 minus 4/9 cos square theta minus 4/9 sine theta cos theta equal to 0. Now from this we can simplify. If we simplify here 1/3 minus 1/9, that will be ultimately 2/9 sine square theta plus this one. Or if we simplify, it will be 2/9 cos square theta, because 2/3 minus 4/9, that will give us 2/9 minus 4/9 sine theta cos theta equal to 0. Now if we take 2/9 common, we are left with sine square theta plus cos square theta minus 2 sine theta cos theta equal to 0. Now here sine theta minus cos theta whole square equal to 0. Now after this what we can say? That this gives us tan theta equal to 1. Now tan theta equal to 1 means theta will be equal to between 0 to pi equation, pi by 4. No other solution, because after that the possibility of whatever we have, that is pi plus pi 4. So only one solution is possible. So just only one solution we can say here, that A intersection 0, pi, this set will have only pi by 4. As the cardinal number is 1, so exactly one solution. Now we take another sum from KVPY 2008. it says that there is a set S, X belongs to R, such that cos X plus cos of root 2x less than. So from the options, what we understand, here the options you can see. The first option is saying, if we just understand what is given in the options. First option is a null set. Second option, option B, S is a non-empty finite set. Is a non-empty finite set. C option, S is infinite. S is infinite. Proper subset of R minus 0. And lastly, we have S equal to R minus something 0. So these are the possibilities which we have. Now, first of all, since here we can understand 0 is a point that has been highlighted by the options, you can say. So from that, we can understand one thing, that we can just verify one thing from the given information, that whether 0 will satisfy or not. So what we say, that we have cos 0 plus cos of root 2 into 0. This is 1 plus 1, that is 2. So that means when we put x equal to 0, it will be definitely equal to 2. It cannot be less than. So here you can see that this is not less than. That means 0 x equal to 0 doesn't satisfy this equation because it attains the value 2. So what we can say, that when x is equal to 0, the expression cos x plus cos root 2x attains maximum value of now. For any other, this one we have understood that when it is we are having x equal to 0, then it will attain the maximum value. But for any other one, then what will happen? So for any other x belongs to R minus something 0, then what will happen? Then we can understand that cos x plus cos root 2x is less than. If we remove equal to if we take the equality condition, equality is possible when both are 1, because we know that is possible only when equality is possible when both are equal to 1. So if we have both equal to 1, suppose if we say here less than equal to 1, if we consider the inequality inequation with the equality, so that possibility is when we can get that cos x plus cos root 2x equals to 2. Then we have the possibility that cos x is 1 and cos root 2x equal to 1. Now, what does this mean? This means cos is equal to 1 means x equal to 2m pi. And root 2x equals to 1 means 2n pi. Now, from this, if we just divide these two equations, then what we get? Then we get root 2x by x equal to 2n pi by 2m pi. That is n by n. That is root. Now, that is not possible. Why? Because root 2 is the irrational number. But n and m are what? When we write the general equation, then n comma n both are integers. Now, when n and m both are integers, then it cannot be possible that root is a rational number. That is, this is a rational number, this is a irrational number. That will contradict the condition. So this is a contradiction. So here we can say that this is a contradiction, which is a contradiction. Why? As root 2 is irrational, which is present in the RHS, and LHS is a rational number that is m by n, where m comma n belongs to 7. So that means so there cannot be any possibility except x equal to 0 that when this expression will take the value 2, which is the maximum value. In all other cases, this will be less than 2. So this shows what that s cannot be equal to 2 except for 0. That is is not equal to 2 for all x belongs to r minus 0. That means switching term means what? That this implies automatically s is less than 2 for all x belongs to r minus 0. And therefore the correct option is D. KVPY 2008. Number of real solution of the equation cos square x sine 2x plus 1 by 1 plus x square cos square x plus secant square x. Now here the number of possible solutions is required. So basically this sum, if we observe carefully, this is actually an optimization problem. Why I'm saying it is an optimization problem, I'll explain. It is an optimization problem which has been converted into a problem of solution of equation. Now, how it is an optimization problem that we have to understand. First of all, just by inspection, we can understand here that x equal to 0 is definitely a solution. Right? When x is 0, this will be 1. When x is 0, this will be 1. When x is 0, this is 1. When x is 0, this is 1. So straight away, we can say that just by inspection, we can say that x equal to 0 is a solution. Now, after that, if we apply here G.M. inequality on the RHS part, here apply G.M. inequality on RHS. So automatically we can understand that cos square x plus secant square x will be greater than equal to 2. So that is what we understand. And here when the equality will hold true, when both of them will take the value 1. Otherwise never possible. Here this is possible when both of them take the value 1. So the RHS part is greater than or equal to 2. And LHS part, if we consider, then each term is at most 1. Here RHS is greater than or equal to 2, and equality will hold true. Equality will hold when each of the term is equal to 1. When cos square x equal to secant square x equal to 1. But if we focus on the LHS part, in the LHS part, what we have? LHS part, the maximum value is 2. Maximum value equal. And when is that possible? When each of the term is equal to 1. Why? Because we know cos square of something is always less than 1, and 1 by 1 plus x square, that is also less than equal to 1. So the LHS part can at most take the value 2, RHS part can at most take the at least can take the value. So that means that equality can hold true when all of them are taking the value 1. And that is possible when? Only when each of the term is taking the same value, that is x equal to 0. So here the only solution is x equal to 0. Each of the term is taking the value 1, that is the only solution. X equal to 0 is the only solution. Here the given condition x1 plus x2 plus x3 plus xn is equal to 5. We have to find the maximum value of max value of sin x1 plus sin x2 plus sin x3. Now here, first of all, if we focus on sin s graph, the sine graph is a downward concave downward. Here we can see that we have sine curve is concave down. Now, if we just draw a sine curve, then we can easily decode that also. And downward we are saying because we are taking the interval from 0 to 1. Okay. So here, if we take any point on the curve, just if we take a point here, the point P, suppose we take the point P as some xi comma sin xi. So these type of points, not only this point, this type of points we are saying, because x1 comma sin x1, x2 comma sin x2, all these type of points. The point here P is just a point, but here I can vary. So you can see here R on, because it's not only one point, a number of points are on the curve y equal to sin x, where x is less than equal to pi greater than equal to 0. So this point is what? Inside the polygon. Here, if it will be inside this one, here if we take this one, try to understand. The here if we take the number of points, here we are taking P is this one. So like this we have a number of points. We have here P1, we have here P2, we have here P3, we have here P4n, up to like this we get to Pn. So basically if we join all these points, then we get a polygon. Here if we join all these points, we get a polygon. So we can just mention that one, that on joining all such points, we get a polygon. Now, once we understand that there is a polygon, after that, what we can say, that sine of x bar. What is sine of x bar? We can say the mean point. This one we can take as mean point. Will definitely lie inside this polygon. Will lie inside the polygon. Here you have got a polygon, so this point will lie inside the polygon. So very simple thing. And this whole part not only over sine, this will lie inside the polygon. Because the mean point means if we add here x1 plus x2 plus x3 up to xn by n, and what is this x sine x bar? Sine whole bar x. It is the bar of sine x. That means sine x1 plus sine x2 plus sine x3 plus sine xn by n. This one is taking, we are taking the average of all the ordinates. It is the average of all the abscissa. It is the average of all the ordinates. That will lie inside the polygon for sure. Now, this is the mean point which we are taking. Because why we are saying mean point? Because the mean of the abscissa is the mean of the ordinate. Now, this will definitely lie on the lie inside the polygon. And there is another point which is x bar sine x bar. X bar, that is the average of the abscissa. If we give the input to sine, that value, that will lie on the curve. So from the graph, if we try to understand the situation, that is here, if we have corresponding to this point, we have x bar. Then this point is, we can see the mean point which we denote as m. This point is m, which will lie inside the polygon. And here, if we take perpendicular, now then we have another point, this one, which you can say as n. Now then n is outside, that is on the polygon. There is x bar sine x bar. Now this will lie on the curve. So naturally we can understand here that this height is mn and this complete height is nn. So from this what I can say that mn is less than n. Now ml is less than nn. So what is ml? ml is here sine x whole bar less than sine x. Now what is the meaning of this? Meaning is sine x1 plus sine x2 plus sine xn by less than sine x bar, that is x1 plus x2 plus xn by. Now from this what we can say that sine x1 plus sine x2 sine xn is less than, now x1 plus x2 plus xn, that is pi given in the questions, that is less than n into sine pi by n. Jensen's's inequality. Now, in Jensen's's inequality, what we have a function. So, first of all, we consider a function fx. So, let fx be twice differentiable function on an interval open bracket a comma b. Function is defined on closed interval a comma b. Function is differentiable in the open bracket and function is defined in the closed bracket. And f double dash x is less than 0 for all x belongs to open bracket a comma b. So what we get here, that it is given that we have considered a function which is double differentiable on the interval a comma b, and the function is defined the closed interval a comma b. F double dash x we have considered less than 0 for x belonging in the open interval. Now in this condition, if this is satisfied, then for every positive integer, then for every positive integer, small n, and for all points, x1, x2, x3, xm in closed interval a comma b, we have f of x1 plus x2 plus xm by m is greater than equal to f of x1 plus f of x2 plus f of xm by m. Now, what we're saying that if this is satisfied, if the function has this characteristics, then if we consider any positive integer m and we take some m numbers in this interval where the function is defined, the closed interval where the function is defined, then we can write f of x1 plus x2 plus x3 up to xm by m is greater than equal to f of x1 plus f of x2 up to xm by m. When the inequality will hold true, or that is when the equality will hold true, that also we'll discuss. That is here we can say moreover, equality holds if and only if the numbers are equal. That is x1 equal to x2 equal to x3 equal to x. Now we try to understand that whatever we have told it here, what is the meaning of all this? Just we take here two numbers instead of taking this m number. Just we analyze the whole thing just by taking two numbers. I consider here a function fx. Let fx be a function defined on closed interval a comma b, and fx is differentiable. Fx is differentiable twice on open interval a comma b. Let us take 2 points. Let x1 comma x2 be 2 points that belongs to open bracket a comma b. We have just considered here the 2 points are there, x1 comma x2, that is belonging to the open bracket a comma b. And here, as we have considered the previous case, here also we'll consider the same thing, that f double dash x less than equal to 0. Now we try to represent this whole situation graphically. We take a Cartesian plane. Here we have y-axis, here we have x-axis. This is x prime, this is y prime, so on. Now since f double dash x less than 0, so this should be concave down. We know in case of maximum minimum also, we have seen that whenever we have a concave down shape, there is a concave downward direction. That time what we have is f double dash x less than 0. So if we just take a car where f double dash is less than 0, and on this we take 2 points, One is the point P, and other is the point Q. Now point P is here x1 comma fx1, and Q is x2 comma fx2. Now we take a point here as R. Now this point is A, the put of the perpendicular, so this is x1 comma 0. Here is the point B, which is x2 comma 0. Here is the point we take as some C, and we take this one as x1 plus x2 by comma 0. Now automatically we will have a point here also, which will be f of x1, f of x1 plus x2 pi. That is the height. Height of this one is RC length is f of x1 plus x2 pi. And if you want to represent R, we can write this one as x1 plus x2 by 2 and f of x1 plus x2 by 2. That is the point R, point of the pointer. So this height is f of x1 plus x2 by 2. Now, if we join these two ends, this is the line PQ, then midpoint of the line segment, midpoint of the line segment PQ is x1 plus x2 by 2, comma, fx1 plus fx2 by 2. So this is what we have. x1 plus x2 by 2, f of comma fx1 plus fx2 by 2. That will be the midpoint of the line segment joining these two things. Now, if possible, that point will take us. There is this midpoint which you have represented that will take us. Aim is x1 plus x2 by 2, comma, fx1 plus fx2 by 2. That is what we have. Now already it has been told that the shape is concave down. So if it's concave down, this is definitely RC is greater than MC. As F double dash is less than 0, therefore RC is greater than MC. Now from this we can see that f of x1 plus x2 by 2 is greater than f of x1 plus f of x2 by 2. Now this is true when we know that this is concave down. Now if it is so that the line, this curve, the straight line, then obviously this will be same. So when this will be equal, that when this RC equal to MC, when it is a straight line. If we get that is a straight line, then these two can be equal. So this is the condition when f double dash is less than 0. Now with this we can say that when the curve is a straight line, when the curve is a straight line joining P and then f of x1 plus x2 by 2 equal to fx1 plus fx2 by 2. So this is what we understood. Now similarly, if it was like this, that f double dash is greater than 0, then we know it is concave arc. When f double dash is greater than 0, that is, if we imagine it in this way, that we have the curve like this. Now, when this possible? When f double dash is greater than 0. So when f double dash is greater than 0, that is concave half shape graph, then we can say that f of x1 plus x2 by 2 is greater than f of x1 plus f of x2 by. So these are the three criteria which we get in an acute angle triangle. In an acute angle triangle ABC, we have to show that cos A plus cos B plus cos C less than equal to 3 by 2. Now, since this is acute angle triangle, since A, comma B and C are acute angle triangle, so A, comma B, comma C belongs to 0, comma pi by 2. Definitely. Now here we take a function hx which is defined by cos x. Now this is just we have considered. We can assume it in this that let hx equals to cos. Now cos x is definitely a function is a twice differentiable function. It is actually more than twice differentiable. It is definitely twice differential. Definitely in the interval twice differentiable function in 0, comma pi by 2. Now, after that, we can just go on differentiating and we can see that what happens minus sine x. And if we differentiate once again, it is minus cos x. Now, this will be definitely less than 0 for all x belongs to 0, comma pi by 2. Because if we take any acute angle and we separate here and minus in front, so this will be definitely negative. Now, since it is negative, that means what is concave down? When concave down, we can apply here Jensen's's inequality. So here we can use using for concave up or concave down, even for straight or straight line also, we can apply this Jensen's's inequality. And we can say here that h of a plus b plus c by 3 is greater than equal to h of a plus h of b plus h of c by 3. Now this gives us cos of a plus b plus c by 3 greater than equal to cos a plus cos b plus cos c by 3. Now cos of a plus b, since it's a triangle, so this should be pi. So pi by 3, that is half. So if you just shift 3 on the left hand side here, we can get that cos A plus cos B plus cos C is less than equal to 3 by 2. And here equality can also hold true because A equal to B equal to C can be equal, and then can take the value pi by 3. So we can say, we conclude here that equality holds true if and only if A equal to B equal to C equal to pi by 3. In an acute angle triangle. In an acute angle triangle ABC, we have to show that tan A plus tan B plus tan C is greater than equal to 3 root 3. Now here we consider that let fx equals to tan x. Now it since it's an acute angle triangle, so this x should belong to open bracket 0, 5. Now in this interval, fx is definitely twice differential. Fx is twice differential. So we can see here f plus x is secant square x. F double dash x is twice secant square x tan x. Now in this interval, secant square x as well as tan x, both are positive. So you can see greater than 0 for all x belongs to 0, 5/2. Now since it is greater than 0, so it's concave R. Now since it's concave R, we can apply Jensen's's inequality. So by Jensen's's inequality, we can see that f of a plus b plus c by 3 is less than equal to f of a plus f of b plus f of c by 3. Now from this tan of a plus b plus c by 3 is less than equal to tan A plus tan B plus tan C by 3. Now we know that A plus B plus C is 5, so it's 5/3, so that is root 3. So we rearrange and we can write that tan A plus tan B plus tan C is greater than equal to 3 root 3. And equality holds true. Equality holds true if A equal to B equal to C equal to 5/3. The next question, it is given for an acute angle triangle. For an acute angle triangle ABC, A, B, C belongs to open bracket 0, 5. We have to prove sin A, sin B, sin C less than equal to 3 root 3 by 8. Now, here, first of all, you understand that here we have to find the product. We have to show that a product is less than this. So, how can we proceed here? We can consider here that let fx equals to ln sin x. And here x belongs to open bracket 0, 5/2. Here the angle can take the value 5/2. So it can be right angle triangle. Though it is given the question acute angle, so we do not take the concept of this one, just we take 0, 5. Now here if we find f test is, it is cos x by sin x, that is cos x. And f double dash x minus cosec square x. Now this will be less than 0 when x belongs to 0 comma pi by 2. That means what? It is concave down. Since it is concave down, using Jensen inequality, we can say f of a plus b plus c, f of a plus b plus c by c greater than equal to f of a plus f of b plus f of c by 3. And from this we can say ln sine of a plus b plus c by 3 greater than equal to ln sine plus ln sine b plus ln sine c by 3. Now, a plus b plus c, here it is pi, so sine pi by 3. Now, ln sine pi by 3, so we can see here ln root 3 pi, and we take here 3, that is, we take it from the RHS. It is ln of sine b sine c. Now, from this we can see ln of root 3 by 2 whole cube greater than equal to ln of sine A, sine B, sine C. And from this we can definitely say, since ln is a strictly increasing function, that sine A, sine B, sine C is definitely less than equal to 3 root 3 by 8. But here we should mention here that why we're doing so, because this strictly increasing function. Ln x is a strictly increasing function. Now, from graphical point of view, if we apply this Jensen without differentiating, that also you can do. Just we analyze it, that how does the effects look like. This x, this is y, this is origin. This is the graph. Now here we can see that fx equals to ln sine x. So here fx is concave downward. So if it's concave downward, now here also if we take 3 points as we take here A, which is A comma ln sine. We take a point B, which is B comma ln sine, and we take C, which is C comma ln sine C. These are the 3 points we take on the curve. Now after we take here A, B, and C, we can form here a triangle. So if you take a form a triangle here, the center will be A plus B plus C by 3, and ln of sine plus ln of sine B plus ln of sine C by 3. The center of the triangle will be this one. Now, correspondingly, if we try to get a point which is corresponding to this abscissa, that it will take as m. That m will be A plus B plus C by 3, and it will be ln of sine of A plus B plus C by 3. Now, here we have to understand one thing. This curve, we cannot say this is the ln x graph. This is sine x, is ln of sine x, it's ln x. Now, when the value is lying in between 0 to 1, or here the values which you'll be getting for A, B, C will be from 0 to pi. So whatever we see, that the nature will be same one. So definitely we can apply this, and after applying this one, we can definitely say that the mean point is this one. It will lie inside and it will lie on. This will lie on the curve and this will lie inside the triangle. Just you can imagine the triangle. These are triangles. Now here the centroid if we get. This is centroid. Now corresponding to that we get a point which is M. So naturally we can understand that height of M from the x-axis is greater as compared to the height of the centroid from the x-axis. So from this we can definitely say that ln of sine A plus B plus C by 3 is greater than equal to ln of sine A plus ln of sine B plus ln of sine C by 3. And then the same expression which I have done in case of Jensen, the same. We can just take this on the right hand side, left hand side, and we can do the rest of the same equation. In a triangle ABC, in a triangle ABC, we have to prove that summation A, comma B, comma C root over of sine A, that is a combination of ABC angle, root over of sine, root over of sine B, root over of sine C, minus root over of sine A is greater than 3. Is greater than equal to 3. We have to prove that in a triangle ABC, root over of sine by root over of sine B plus root over of sine C minus root over of sine A greater than equal to 3. First of all, we'll try to bring here the sides of the triangle. Here it is given in terms of angle. Instead of angle, if we take it in terms of sides, it will be quite helpful for us. So we'll try to bring this expression in terms of side of the triangle instead of angle. So what we take, here we apply sine rule in the triangle ABC. So from sine rule, in triangle ABC, A by sine A equal to B by sine B equal to C by sine C equal to 1. And R is circumradius. So from here we can say that sine A equal to A by 2R, sine B equal to B by 2R, and sine C equal to C by 2R. Now we utilize this result in this given expression. So we have A, B, C sides of the triangle and under root of A by 2R, under root of B by 2R, plus under root of C by 2R, minus under root of A by 2R. Now we can clearly understand that root r, we can cancel out. And we'll be getting here summation A, B, C sides is root A by root B plus root C minus root A. So this is what we get. Now if we decode this statement, that is summation of a summation where we are taking A, B, C combination root A by root B plus root C minus root A. If we just decode this, we get root a by root b plus root c minus root a plus root b by root a plus root c minus root plus root c by root a plus root b minus root c. We get this expression. Now we have to find the minimum value of this expression. How can we do that? If we try to simplify this one further, then it might help us. So in order to simplify this one, here we take that let x equal to under root of b plus root c minus root a. Now y equal to under root of a plus root c minus root b. And we take another quantity z, which is root a plus root b minus root c. So we have got the denominator values in terms of the single variable. Now the problem is we have root a, then how can we write root a? We can say here that we have root a equal to y plus z by 2. If we simply add these two expressions, we'll get twice root a, so by 2. Similarly, to get root b, we can write here half of. To get root b, we get it as half of x plus, and root c will be half of x plus 1. Now we substitute these values in the above expression. Then we get it is y plus z by 2x plus x plus z by 2 plus x plus 1 by 2z. Now this is half of y by x plus z by x plus x by y plus z by y plus x by z plus y by z. We get this. Now here all the terms are positive terms because these are the, here if we see this one, that this plus this should be greater than b. Definitely this one, because root b plus root c should be greater than a. Why? That we can show here. Root b plus root c whole square is definitely greater than b plus c, and that is definitely greater than a, because some of the two sides of a triangle greater than the third side. Now if we take the square root of this, that is root b plus root c, that will be greater than root a. So naturally, if we take root a towards the left side, then we get greater than 0. So this shows x greater than 0. And similarly we can say y comma z greater than 0. So naturally their ratio are also greater than 0. So definitely all of them should be greater than 0. Now here we have 1, 2, 3, 4, 5, 6 quantities we are getting, which are greater than 0. Now obviously if we have got here this one, we will not apply EMGM over directly all of them. Since we are trying to get the minimum value, automatically this will come to our mind that since the quantities are positive, we can apply EMGM. What we can do in a very simple manner. These two we can take together, and then we can take this one and this one together as a one pair, and lastly this one and this one we can take as one pair. So what we can say that this is half of y by x plus x by y plus z by x plus x by z plus z by y plus y by z. Now this whole thing should be greater than equal to on application of AMGM. So we can say that this whole thing is greater than equal to half of 2 plus 2 plus 2, and that is 3. Now this given expression will be greater than or equal to 3, while equality sign will also hold true equality sign holds true when we have this term equal to this term, that is x equal to 1. When x equal to y, that means what? A equal to b, because if we equate x equal to y equal to c, that is only possible when a equal to b equal to c. When we say that equal to will hold true, when these terms are equal, these terms are equal, these terms are equal. That is x equal to y equal to z. When x equal to y equal to z, a equal to b equal to c. So here we say when a equal to b equal to c, that is triangle is equilateral. When a triangle is equilateral triangle, we have a triangle ABC, and here we have to show we have to prove here that a square plus b square plus c square greater than 4 root 3 del, where del represents the area of the triangle. Area of the triangle ABC. And the small c, with the usual notation, we know these are the length of the sides of the triangle ABC, where small a is the side length of the side BC, B is the length of the side AC, and C is the length of the side AB. So that we know. Here we have to coordinate the square of the side with the triangle area. To the statement which we require to prove, this shows that we have to establish a relation between the squares of the side and the area of the triangle. So first of all, we try to bring the square of the sides. For that, we take the help of cosine rule. So by cosine rule, we can write a square equal to b square plus c square minus 2y bc cos. But from the statement which we need to prove, we understand that we need a square plus b square plus c square in one side. So we add a square plus b square on both sides. We add b square plus c square on both sides, so that we can get a square plus b square plus c square on one side. So adding b square plus c square on both sides, and we get a square plus b square plus c square equal to 2 times b square plus c square minus twice bc cos a. So we have got one part of the required proof, that is we need here a square plus b square plus c square. We have got that. Now we make this as equation 1, and now we try to get the other, that is the area of the triangle. Now what do you know? We know triangle can be written as half BC sine. So if it is half BC sine A, so from fourth triangle we can write this is twice BC sine. Now we have to show that this one better than this one. So for that, if we can show that this one minus this one, that is the difference of these two, is greater than 0, then also we are done. But for that, we need here 4 root 3, which we don't have here. But we can understand that for 4 root 3, we have just multiply on both sides by root 3. So now we take, or you can just take one more step, and then we can do the required calculation. So 4 root 3 triangle will be twice root 3 BC sine A, which we take as equation 3. Now, subtracting 3, equation 3 from 1. Now, if we subtract equation 3 from 1, we get a square plus b square plus c square minus 4 root 3 triangle. And from this we can say that twice b square plus c square minus 2bc common, and we get here cos a minus root 3 sine. Now here we had minus, now it is also subtracted, so this will be ultimately minus minus plus, because minus has been taken common, so this will be plus. Now we can simplify this one as twice b square plus c square minus 2bc. Now this one we can see here that we can simplify this one. How we can simplify? We can just take here a half and multiply by a 2 outside. So what we can do here, we can just, because we know that whenever we have this format, a cos theta plus b sin theta, we try to convert this as sine of theta plus alpha or cos of theta plus alpha. So in order to do that, here what we do, we take here a 2 and divide by a 2. So it is half of cos plus root 3 by 2 sine. Just you have to bring the whole expression as a cos or sine of 1x. So we can write here 2 times b square plus c square minus 4bc into cos. Now here we can say cos of a minus pi by 3. So this we get as cos a minus pi by 3. Now cos theta, cos of any angle we know that will be less than 1 definitely. Cos of any angle should be less than 1 definitely. Now that means this is maximum value of 1. We take this one as 1, then this expression reaches to its minimum value. Here, when cos a minus pi by 3 equal to 1, then the expression twice b square plus c square minus 4bc into cos of a minus pi by 3 reaches to its minimum value. Now why minimum value? Because if we separate the maximum part, then automatically the expression will take the minimum value. That means that this implies that we can write now 2 times b square plus c square minus 4 times bc cos a minus pi by 3 is greater than equal to 2 times b square plus c square 2 times b square plus c square minus 4 times bc. Now this is same as 2b minus c whole square. Now we know that square of any quantity here, real quantity, should be greater than equal to 0. Square of any real quantity should be greater than equal to 0. So this should be greater than or equal to 0. Now we have started with the expression a square plus b square plus c square minus 4 root 3 triangle. So that is greater than equal to 0. And therefore we can say a square plus b square plus c square greater than equal to 4 root 3 triangle. Hence proof. So this is a very important expression, and it's a standard expression for Jensen's's inequality. In a triangle ABC, we have to show 3 by 2 less than equal to a by b plus c plus b by c plus c plus c by a plus b less than this one, the famous inequality, Nesbitt's inequality. So this we are going to do. Now, this is in a triangle. So these are the sides of a triangle. So naturally they will be positive number. So we take here three sides. That sum of the three sides. Here, if we just draw the triangle, then we can understand. Just I'm drawing it in short. A small triangle we have taken, ABC. So this A, B, and C. Now we have opposite to vertex. Say we have small a, which is the side BC. Opposite to vertex, we have small b, and opposite to vertex C, we have small c. Now we take here three quantities: A plus B, B plus C, and C plus C. Since these are the ABC, the measure of the sides of the triangle, so naturally their sum will be greater than 0. Now here we apply AMGM on these three positive quantities. So applying A greater than equal to G. So A plus B plus B plus C plus C plus A by 3 greater than equal A plus B into B plus C into C plus A to the power of 1 by 3. So just we have taken three quantities and over them we have applied AM greater than equal to G, and we mark this as equation 1. Now, when A plus B, B plus C plus A is positive quantity, then we must have, we have 1 by A plus B, 1 by B plus C, and 1 by C plus A also greater than 0. So over this also we can apply AMG inequality. So applying AM greater than equal to GM again, we get 1 by A plus B plus 1 by B plus C plus 1 by C plus A by 3 greater than equal to 1 by A plus B into 1 by B plus C into 1 by C plus A, 1 by C plus A to the power of 1 by 3. This we mark as equation 2. Now, if we just multiply equation 1 and 2, just if we multiply these two equations, then we can see right hand side will be eliminated. That we can eliminate the right hand side. Now, after the right hand side gets eliminated, this will be 2 times A plus B plus C, and this one already we have. And in denominator we have a 9. So what we get on multiplying equation 1 and 2, on multiplying equation 1 and 2, we get 2 times A plus B plus C into 1 by A plus B plus 1 by B plus C plus 1 by C plus A greater than equal to 9. Why? Because it is 3 into 3, so greater than equal to 9. Now we can simplify this one further, and we can write here that A plus B plus C into 1 by A plus B plus 1 by B plus C plus 1 by C plus A greater than equal to 9. Now we just take this factor and multiply with each of the terms. Then what we get? A plus B by A plus B, 1 plus C by A plus B. So we can write here 1 plus C by A plus B plus B plus C by B plus C, that is 1, plus A by B plus C, plus C plus A, C plus A, 1, plus B by C plus C, greater than or equal to 9. Now this gives you C by A plus B plus A by B plus C plus B by C plus A greater than or equal to 9 by 2 minus 3. 1 plus 1 plus 1, that is 3. So 9 by 2 minus 3. Now this gives us C, or we can rearrange this as A by B plus C plus B by C plus A plus C by A plus B greater than or equal to 3 by 2. So this is one part of the required expression. Now we move on to the next part where you have to show that this sum is less than. Now if you see here, first of all, B plus is definitely greater than A, C plus A definitely greater than B, and A plus B greater than C. Now we can start it in this way, that is A by B plus C, where we know that B plus is greater than A. We can write that this is less than A plus A by A plus B plus C. Now, why you can write this one? Just we'll take that, just will show that by an example. Here we know what, first of all, that A less than B plus this will. So here it can be done in two process. A less than B plus C. Now, if we add a A on both sides, then we can say that 2A less than A plus B plus. Obviously, we can say, because just if we add here A, we can say this one. So this one less than this one. That means so here also this quantity will be less than 1. Here also this quantity will be less than 1. Now, how can we say that A by B plus C less than 2A by A plus B plus C? Very simple logic this one. Suppose we have 3 less than 3 by 4. Now we know 3 less than 4. Now definitely when we add 3 plus 3 by 4 plus 3, this becomes what? 6 by 7. So naturally what happens? This ratio becomes greater than this ratio. So here also you have applied the same concept. So A by B plus C less than A plus A by A plus B plus C. Similarly, we can say, similarly, B by A plus C, we can say less than B plus B by A plus B plus C, which is 2B by A plus B plus C. Again, C by A plus B less than C plus C by A plus B plus C, which is 2C by A plus B plus C. Now we are adding, so on adding, we get A by B plus C plus B by A plus C plus C by A plus B less than 2 times A plus B plus C whole divided by A plus B plus C, and that's 2. So hence the second part is proved. So we have taken the first part, which was this one, which I proved as 3 as equation 3. Now this we take as equation 4, and from 1 and 4, from 3 and 4, we conclude that A by B plus C plus B by A plus C plus C by A plus B is less than 2 greater than equal to 3. Sin theta plus cos theta equal to 1. That sum of the two quantities is equal to 1, and both the quantity are greater than 0. And we have to show here, we have to show 1 plus cosec theta into 1 plus sec theta greater than equal to 9. We have to show this. Now, first of all, sin theta and cos theta both positive number, and their sum is given. Now, from this only, this gives a hints, and from this expression, from this given expression, our thinking pointer can move in this so that we have to apply AMG, because this is just it has been given directly the form of the conditions of AMG. So definitely we'll be applying here AMG. So by AIM G.M. inequality, we can apply over sin theta cos theta. So sin theta plus cos theta by 2 greater than equal to under root of sin theta into cos theta. Now from this we can say that 1 by 2 greater than equal to under root of sin theta cos theta. We can apply this because both the quantities are given positive number. So we can definitely apply this. Now from this, if we simplify further, we can see that sin theta cos theta is less than equal to 1 by 4. And we mark this as equation 1 because this is the conclusion which we have drawn from this given information. Now we come to the statement for which you have to prove. This is just whatever the clue was given from the beginning. This was just like a hint that we have to apply this AMG inequality. Now here we come to this expression. Now here we take that let P less than equal to 1 plus cosec theta into 1 plus sec theta. There we say P is the minimum value of this expression. Now this expression, if we simplify a bit, then we get that P less than equal to 1 plus 1 by sin theta plus into 1 by into 1 plus 1 by cos theta. Now definitely we can proceed with this only, but we can take here sin theta as some quantity x just for making the calculation easy, and cos theta as y. And here x and y both greater than 0 because cos theta and sin theta both greater than 0. So the expression which I have got here reduces to P less than equal to 1 plus 1 by x into 1 plus 1 by 1. Now we can simplify this one further and we can write P less than equal to x plus 1 into y plus 1 by x. So if we simplify this, then we can write Pxy less than equal to x plus 1 into y plus 1. And we have multiplied both sides by xy, no change of inequality sign because x and y both positive. So naturally when we multiply, no change of inequality sign. Now here we can further simplify Pxy less than equal to xy, x into y, xy plus 1 into x, that is x plus y plus 1. Now we have seen that sin theta plus cos theta equal to 1, that's given in the expression. So automatically here x plus y will be equal to 1. Because since sine theta plus cos theta equal to 1, so here x plus y will be also 1. So 1 plus 1. Why? As we can write here, as sine theta plus cos theta equal to 1, this implies x plus y equal to 1. Now from here, we can say that x, y taken common, so it is p minus 1 less than equal to 2. And from this we can say that x, y less than equal to 2 by p minus 1. Now from equation 1, if we say here, because here in equation 1 we have seen that sine theta into cos theta less than equal to 1 by 4. And here we have got sine theta cos theta less than equal to 2 by p minus 1. Now in one particular case, we can have same value of x and y, minimum value or maximum value. So from 1 and 2, from 1 and 2, we can say that 2 by p minus 1 equal to 1 by 4. The factor, the product x is reaching maximum value to this is taking the maximum value as 2 by p minus 1. The product xy is taking the maximum value as 2 by p minus 1 here. Previously in equation 1, what we have seen, sine theta cos theta is taking the maximum value as 1 by 4 here. Now from these two expressions, we can say that these two things, these two conditions should be same. So from here we can say that 8 equal to p minus 1. And therefore p is equal to 9, which is the required value. In an acute angle triangle, in an acute angle triangle ABC, cot square A plus cot square B plus cot square C greater than equal to 1. So this is what we need to do. The approach here is very simple because it is given an acute angle triangle. So first of all, from the triangle, angle sum property of the triangle, we can write that A plus B plus C equal to 5. So this is just the angle sum property of a triangle. Angle sum property of a triangle. Now from this we can say that A plus B equal to 5 minus C. Now it is acute angle triangle. That means no question of any angle being odd multiple of 90. So we can write tan A plus B equal to tan 5 minus C. So here we apply the formula of tan A plus B, which is tan A plus tan B by 1 minus tan A. Even we could have applied here for formula also. So we can write here that tan A plus tan B plus tan C equal to tan A, tan B, tan C. This is a standard result, which is better if we keep in mind. Always, whenever we have A plus B plus C, we can apply this. Now, if we divide throughout by tan A, tan B, tan C on dividing throughout by tan A, tan B, tan C, we can say here tan A by tan A, tan B, tan C plus tan B by tan A, tan B, tan C plus tan C by tan A, tan B, tan C equal to 1. Now this gives us that cot B cot C plus cot A cot C plus cot A cot B equal to 1. We mark this equation as 1. Now this is also a well-known result. Even we can use this result directly also for this type of cases. Now we have to show cot square A plus cot square B plus cot square C greater than or equal to 1. So even we can start it in this way, that we have cot square A plus cot square B plus cot square C minus 1. Because if we can show that this is greater than or equal to 0, it is non-negative, then we are done. Now we can just substitute the value of 1. So cot square A plus cot square B plus cot square C minus cot B cot C plus cot A cot C plus cot A cot B. Now here we try to apply complete square method. So we take a half outside and multiply by 2. So twice cot square A plus twice cot square B plus twice cot square C minus 2 cot B cot C minus twice cot A cot C minus twice cot A cot B. Now this gives us half outside cot A minus cot B whole square plus cot B minus cot C whole square plus cot C minus cot A whole square. Now this must be sum of the C squared. So this must be greater than or equal to 0 as the sum of the C squares. And from this we can conclude that cot square A plus cot square B plus cot square C is greater than or equal to 1, which is what we need to prove. Now we take the next sum where we have to show that for an acute angle triangle, we have to show, or we can say we have to prove that sine into sine B into sine C is less than equal to G root 3 by A. In this problem, definitely we will be using G.M. inequality. The reason is very simple, because the clue in the question, the clue is given. There is acute angle triangle. That means here A, B, C are all acute. So definitely sine A, sine B, sine C are positive. So we can definitely use G.M. inequality. But for that we need here find the value of that is what is the maximum value of sine square plus sine square B plus sine square C. So our first intention is to get what is the value of sine square A plus sine square B. So we started in this way that we have sine square A plus sine square B plus sine square C will be reduced as half common 1 minus cos 2 plus 1 minus cos 2 and sine square C we keep as it is. Now from here we can write 1 minus 1 by what will be Here 1 plus 1 2 by 2 that is 1 minus half of cos 2 plus cos 2 cos 2 plus cos 2 and sin square c we keep as it is. Next we get 1 minus half into 2 cos a plus b into cos a minus b. Plus we have sin square c which we can write as 1 minus cos square c. We are trying to put it in terms of cos. The reason is here we have a plus b which can be compared to cos c. Now here what we can write? We can write here 1 plus 1 that is 2 minus. This will give us minus cos c into cos a minus b and this one as it is. Just we write it in this format. The reason is here we have got minus into minus plus, so here we can easily understand that once we take cos c common, we'll be left with here cos a minus b and minus cos c from here, which we can write as plus cos a plus b. So this is what we can write. Here we can write 2 plus cos c into cos a minus b minus cos square c. This can be written as less than equal to 2 plus cos c minus cos square c. Here, why we are writing less than equal to? Because we have taken the maximum value of cos a minus b. As why we have written this one, we mentioned here as greatest value of cos a minus b is equal to 1. So that is the reason why we have written less than equal to. Now this one we can further simplify and we can write 2 minus cos square c minus cos c. This can be written as 2 minus cos square c minus 2 cos c into 1 plus 1 by 4 and here also 1 by 4. Actually here both are plus 1 by 4, there is a minus outside. So ultimately this is minus 1 by 4. So to neutralize we have taken 1 plus 1 by 4 and from this we can easily understand the whole expression the whole expression which is sine square a plus sine square b plus sine square c is definitely less than or equal to 2 plus 1 by 4 which is 9 by 4. So this is given as the maximum value of sine square plus sine square plus sine square c. And the reason why we have taken this inequality, the reason is that we know in the given sum a, b, c are active. Sine, sine b and sine c are greater than 0. Now, after that, we can apply here AMG inequality over sine square A plus sine square B plus sine square C greater than cube root of sine square A, sine square B, sine square C. That is, here we are using AMG inequality. This is just we are using AMG inequality. Now, this the reason for finding this inequality is just to utilize this one here. Since this whole expression is less than this one, and when this is the maximum value, definitely this will be less than the value when you replace this one by 9 by 4. That is what we get here. We get here sine square sine square sine square c to the power of 1 by 3 less than equal to 9 by 4 by 3, which is 3 by 4. Now we can further simplify this one, and we can write that sine B sine C to the power of 2 by 3 less than equal to 3 by 4. And from this we can write sine B sine C is less than equal to 3 root 3 by 8. In an acute angle triangle, tan square A plus tan square B plus tan square C is getting equal to 9. Now, this is a very simple sum, just one result we have to use, which we know in an acute angle triangle. In any acute angle triangle, we can write tan A plus tan B plus tan C equal tan A, tan B, tan C. These two are equal and both are greater than equal to 3. Now, how can we utilize this one in this present proof? That is simple use of G.M. inequality again. So we'll be applying this G.M. inequality on tan square to tan square C. So tan square A plus tan square B plus tan square C whole divided by 3 greater than equal to cube root of tan square A tan square B into tan square C. Now from this, what we can do, here we can write tan square A plus tan square B plus tan square C is greater than equal to 3 into. Now this one we know is always greater than equal to 3 into. So this whole value is greater than equal to this one. So when it is minimum, definitely it is greater than that one. So here we can utilize that value, that is 3 root 3 to the power of 2 by 3. Now this one simplification, what we get? It is 3 to the power of 3 by 2 into 2 by 3. That is 3 into 3, which is 9. Hence, it is given in the question that A comma B greater than 0 and A plus B equals to pi by 3. Here we have to find maximum value of tan and n. We have to find a maximum value of tan. Now, first of all, if we observe here, A and B greater than 0, so two positive number, angles are both positive, and their sum is pi by 3. So that means both the angles should be acute angle. Since here we can say that since A comma B greater than 0 and A plus B equal to pi by 3, so both the angles are acute. Now, when both the angles are acute, the quantities which we need to, for which we, the part of which we need to find the maximum value, this quantity should be positive. That is, tan A comma tan B greater than 0. So, since both are greater than 0, we can definitely apply AMG. So, apply AM greater than equal to GM on these two quantities. So, we can say here tan A plus tan B by 2 greater than equal to under root of tan and tan. So this is we can keep as equation 1. Now one thing is given here, one another information that a plus b is pi by 2. So since a plus b is pi by 2, you can say that tan of a plus b equal tan pi by 3. Now tan pi by 3 is root 3. Now here tan a plus tan b by 1 minus tan a tan equal to root 3. Now from this what we get, tan a plus tan b equal to root 3 1 minus tan a tan. This we take as equation 2. Our intention to get tan a tan. Now if you observe it carefully on this first expression, first inequality, we can see here that here we have tan a tan, but we have a term tan a plus tan. Now here we from the second equation we can see that tan a plus tan b is equal to root 3 1 minus tan a tan. That means this can be expressed in terms of tan a tan. Now if we substitute this value here and try to solve, then we can find the maximum value of tan a tan. So what we do, from 1 and 2 we can write, from 1 and 2, from 1 and 2 we can write here root 3 into 1 minus tan a tan b is greater than equal to under root of tan a tan, under root of tan a tan. Root 3 into 1 minus tan a tan by 2 greater than equal to root over of tan a tan. Now for simplification, we take that tan a tan equal to some p. Now we substitute in the above equation, so it is root 3 into 1 minus p is greater than equal to 2 times root 3. Now from here we can simplify it further and we write 3 into 1 minus p whole square greater than equal to 4. Now from this we can say that 3p square minus 10p plus 3 greater than equal to 6. Now we can simplify this one further, 3p square minus 9p minus p plus 3 greater than equal to 6. Now here 3p we take common, it is p minus 3 minus 1 common, p minus 3 greater than equal to 6. Now p minus 3 into 3p minus 1 greater than equal to 6. Now p minus 3 into p minus 1 by 3 greater than equal to 6. Now from this, if we simplify using Webicab method, we see it is 1 by 3, this is 3, plus minus plus. So here what we get, that here either p is greater than 3 or p is less than equal to 1 by 3. Now here we are trying to find the maximum value. P cannot be greater than 3. If we take p greater than 3, then the product will exceed infinity. But here we have a restriction. We have a plus b equal to pi by 3. So that cannot be going as it is having the minimum value root 3 and it is going on and on. It cannot be possible. So here, according to the condition given, that a comma b greater than 0 and a plus b equal to pi by 3, we can say here that p is less than equal to 1 by 3. So the maximum value which we are looking for is 1 by 3. Given x belongs to open 0, close to pi by 2. And we have to find here, we have to find the minimum value of, we have to find the minimum value of 9x square sine square x plus 4 by x sine x. We have to find the minimum value of this expression. We have to find the minimum value of this expression. Now, here it is given x is greater than 0 and the angle is lying from 0 to pi by 2. First of all, the given expression for which you have to find the minimum value, will simplify this. So if we simplify, we get here 9x sine x plus 4 by x sine x. Now both these quantities are positive because x is greater than 0, less than or equal to pi by 2. So here we can say that 9x sine x comma 4 by x sine x greater than 0. So applying m greater than or equal to 0. So after applying m greater than or equal to 0, we get 9x sine x plus 4 by x sine x by 2 greater than or equal to under root of 9x sine x into 4 by x sine x. Now this gives us 9x sine x plus 4 by x sine x greater than or equal to 2 into 6, that is 12. That is the minimum value is 12. Now the thing is that whether this will be possible for this expression to attain this minimum value. When this will be attained, we know the equality holds true when the terms are equal. So we can say here that minimum value is attained when 9x sine x equal to 4 by x sine x. Now this says that x square sine square x equal to 4 by 9. Now the next question is that is it possible for this function to attain this value? To understand, since pi by 2 is greater than 1, x sine x being continuous function does attain the value 2 by 3 for some x belongs to open 0 closed pi by 2. Now here we will understand this concept more clearly. Pi by 2 greater than 1, that means here when we put x equal to pi by 2, then this will become 1. And here you can easily understand that actually this concept is correlated with the IM intermediate value theorem. So from that concept, what we can say that when we put f of 0, this will be 0. When we put f of pi by 2, so that will be pi square by 4. Pi square by 4 is definitely greater than 1, and this value is less than 1. So what we say here, first of all, x is a continuous function. So if we take, let fx equals to x sine x. Now RH, that is limit x into 0 plus fx equal to 0. F of pi by 2 equal to 1 into pi by 2, which is greater than 1. So, by using intermediate value theorem on fx equal to x sine x, which is a continuous function in open bracket 0 comma pi by 2 as per the given interval. So fx not equals to 2 by 3 for some x not belongs to 0 comma pi by 2. So that's the concept of intermediate value theorem. So this shows that function will definitely take the value 2 by 3 for some value of x not lying in 0 comma pi by 2. Hence the minimum value will be definitely obtained. A equal tan alpha tan beta plus 5. B equal tan beta tan gamma plus 5. C equal tan alpha tan gamma plus 5. Here alpha beta gamma are all positive. Alpha beta gamma are all positive. And alpha plus beta plus gamma equal to pi by 2. We have to prove here. We have to prove that root A plus root B plus root C less than equal to 4 root 3. We have to prove this one. First of all, whenever this type of expression we have, or we have root A plus root B plus root C, which we have to prove, generally what we do, we try to deal with the square of this. It is comparatively easier. Because here all the three rational part we have. So we started in this so that we have plus root B plus root C whole square. So then we'll get A plus B plus C plus twice under root AB plus twice under root BC plus twice under root AC. Now from this we can say that root A plus root B plus root C whole square is less than equal to A plus B plus C plus A plus B plus B plus C plus C plus A. Now, why it is so? How we have got this? We have got this by G.M. inequality. We have got this by G.M. inequality. That is here we have seen alpha, beta, gamma positive. So that means what A, B, C all are positive. Since alpha, comma, beta, comma, gamma greater than 0. Therefore, A, comma, B, comma, C greater than 0. Now just we apply AMGM over AN. So AMGM inequality on A and B. If we apply, what we get? We get here A plus B by 2 greater than equal to under root of A. That means twice root over of AB is less than equal to A plus B. So this is just we have taken only one part since they are all symmetrical. So definitely we can get the other result as like this one. So this expression we can say that root A plus root B plus root C is less than equal to this. Now this means what? 2A plus 2B plus 2C plus A plus B plus C. So from this we can say that this implies root A plus root B plus root C whole square less than equal to thrice A plus B plus C. 3 times A plus B plus C. Now here A we know, B we know, C we know. So we can just substitute the result here. So we can say here that root A plus root B plus root C whole square less than equal to 3 times if we put the values tan alpha, tan beta plus tan beta, tan gamma plus tan alpha, tan gamma plus 15 because 5 plus 5 plus 5, 15. As alpha plus beta plus gamma equal to pi by 2, we can write alpha plus beta equal to pi by 2 minus gamma. Now from this tan of alpha plus beta equal to tan of pi by 2 minus gamma. Now tan pi by 2 minus gamma means quad gamma. And quad gamma means 1 by tan gamma. Now we just after the formula tan alpha plus tan beta by 1 minus tan alpha tan equal to 1 by tan gamma. Now we cross multiply. So after cross multiplication we get tan alpha tan gamma plus tan beta tan gamma equal to 1 minus tan alpha tan. Now tan alpha tan beta plus tan beta tan gamma plus tan alpha tan gamma equal to 1. Now just to substitute this result here in the above expression. So using this result we write root A plus root B plus root C whole square is less than equal to 3 times 1 plus 15. So that is 40. So from here we can say that therefore root A plus root B plus root C is less than equal to 4 root C. Hence proof. It is given alpha, beta, gamma greater than 0 and alpha plus beta plus gamma equal to pi by 2. We have to prove under root of tan alpha tan beta plus root over of tan beta tan gamma plus root over tan alpha tan gamma less than equal to under root of 3. So first of all, what you observe, the two things are very important here. That here the given expression is in a irrational term. This is a irrational term, this is a irrational term, this is a irrational term, and this is a perfect square. So what we do to in order to simplify this one, at first we take the let A equal tan alpha tan. Just we are taking this so that we can simplify very easily. B equal tan beta tan gamma, and C equals to tan alpha tan gamma. So now what we have root A plus root B plus root C. So we take it as a whole square so that we can remove the radical sign. So this is A plus B plus C plus twice root over of AB plus twice root over of BC plus twice root over of C. Now alpha, beta, gamma are positive. So naturally tan alpha, tan beta, and the sum is 90. So definitely this tan alpha, tan beta, tan gamma, and tan alpha, tan gamma should be positive. So here we can mention that as alpha, comma, beta, comma, gamma greater than 0, and alpha plus beta plus gamma equal to pi by 2. So A, comma, B, comma, C definitely greater than 0. Now we apply A greater than equal to G for A and B. So we can say here A plus B by 2 greater than equal to AB to the power of half. That is, we can say A plus B greater than equal to twice under root of AB. So now from the above expression we can write here root A plus root B plus root C whole square is less than equal to A plus B plus C plus A plus B plus B plus C plus C plus A. Because what we understand that the maximum value of this one is what? A plus. So this is less than equal to, so the maximum value of this product is A plus. Now we can write that this is equal to 3 times A plus B plus C. Now when we add A plus B plus C, since alpha plus beta plus gamma equal to pi by 2, so the result should be 1. So this is 3. Why? As we can say as A plus B plus C equal to tan alpha tan beta plus tan beta tan gamma plus tan alpha tan gamma equal to 1, as alpha plus beta plus gamma equal to pi by 2. And therefore what we get that root A plus root B plus root C is less than equal to root 3, which is the required expression.